states of matter song. Here we go. Solid, liquid, and gas. The three states of matter, they all have mass. Solid, liquid, and gas, they all have mass. Oh yeah. A solid is firm, a solid is hard. Just like the rocks in your backyard. A liquid is wobbly, a liquid is loose. Just like water, or milk, or juice. A gas is the trickiest one to me, because a gas is something that you cannot see. The helium gas in your balloon makes it float all around the room. Come on! Solid, liquid, and gas. The three states of matter, they all have mass. Solid, liquid, and gas, they all have mass. One more time, you guys, come on! Solid, liquid, and gas. The three states of matter, they all have mass. Solid, liquid, and gas, they all have mass. Alright.
The aim of the experiment is for household liquids to turn solid when frozen and to melt and become a liquid again, as well as evaporate when placed over heat. For the experiment, the first thing we do is place the liquids in an ice cube tray. For this experiment, I'll be using water, cordial, tomato sauce, and yogurt. After you place all the liquids in the ice cube tray, place the ice cube tray in the freezer. After each hour, look at the ice cube tray and make some observations. After the first hour, the water and yogurt had fully frozen. After 2 hours, the cordial had frozen, but even after the third and fourth hour, the tomato sauce still hadn't frozen. So we left this overnight, and it froze overnight, although it was still quite sticky in the morning. Once all of the liquids were fully frozen, light 4 tea light candles and place each liquid cube one at a time in the tray using tongs. Hold the tray over the heat and begin to observe what your liquids are doing. The ice started to melt quite quickly, and we started seeing water in the tray very early on. In this video you can see the ice cube melting and moving around as it moves in its water. It started to evaporate not long after this. Ice fully melted. Next we went on to the cordial. As you can see at the start, there is very little melting, but after about 12 seconds it is starting to melt, and by 4.5 minutes the ice cube was fully melted. Next we went on to the yogurt ice cube, and this ice cube was very thick. Now it only took 4 seconds to start melting, but it took close to 10 minutes to fully melt. It was so thick it barely moved while it was melting. We melted the ice cube of the tomato sauce. This one was interesting because the ice cube started to melt as soon as it was taken out of the tray, and by 26 seconds in it had already started to evaporate. It only took close to 5 minutes to fully melt. Some of our observations during the experiment was that the tomato sauce took quite a while to freeze, and then it started to melt instantly when taken out of the ice cube tray. I also observed that the thicker liquids, like the yogurt, stayed in the same place when melting and evaporating, and because of how thick they were, it was hard to tell when they were fully melted. There would be a safety risk in this experiment of fire, although with appropriate equipment such as tongs like I used or a peg, as well as adult supervision, a stage 2 student could easily do this fun experiment. Finally, this experiment can be varied with different household liquids, and it'd be interesting to see this comparison.